So the next speaker is Davies Iyanuoluwa, a ROS developer from Nigeria.
Okay, and Davies is going to teach us about how to perform mapping and localization by using some of the packages included in ROS2. And Davies, are you ready? Let's see if he is ready. I cannot hear him.
Can you hear me?
Oh, yes, now. Yes, we can hear you. Excellent. Yeah. So we can see now your screen. Then the audience is all yours. Go ahead, Davies.
Yeah, thank you. Thank you, Grado, for inviting me over for this ROS presentation. And I'm so glad. Yeah, so my name is Davies Iyanuoluwa Ogunsina, a Nigerian robotics engineer who works for Robotics, Robotica in the UK. And I'm a robotics software engineer and also a roboticist. Yeah. So today I'll be talking about mapping and localization using ROS2. Can you hear me? Can everyone hear?
Yes.
Yeah, good. So I'll be talking about mapping and localization using ROS2. Yeah. In this ROS jet, what you're going to learn is about mapping and how to localize your robots using ROS2. So I've already talking about who am I. You can connect with me on LinkedIn, ROS Discourse, email, my GitHub account, company website itself. So the first thing we need to do and know about when we're talking about mapping is what is a map? Yeah. So basically, we'll talk about what is a map. So a map is like a representation of an environment. It's like, I call it a blueprint of the environment, of an known environment. In this sense, is where the robots can be able to localize itself in the map, able to send parts or trajectories to the robot to be able to go from point A to point B. And mapping has always been a very, very core figure in robotics, and when it has to come to SLAM, because you need a map for a robot to be able to localize itself in that map, able to send go coordinate from point A to point B. And when talking about mapping, you need sensors in which you are required to use a mapping. Like for example, now we need a LiDAR sensor. A LiDAR sensor can be a 2D LiDAR or a 3D LiDAR. There's the type of LiDAR which I use on my robots right here, which is a YD LiDAR I use for my robot. That's the 2D LiDAR for indoors. Then you can use a 3D LiDAR level than the rest. So there are also cameras, can be stereo cameras or RGB cameras. Now, I already spoke about what the map is. So right now, what we need to do right now is to spawn our robot into Gazebo World. Now, talking about Gazebo World, the robot has to be in a world for us to be able to map that world and for us to localize our robot in that world. Now, I'm going to open my web shell. What's right here? So everybody following? Hello. Hello.
Yeah.
What's the problem?
Everybody's following.
So everybody following?
Yes. Don't worry. It's we are going and.
So the first thing you need to do, the audience does copy this, which spawns the robots. I'm trying to spawn the robot into Gazebo World. So I'm going to open my terminal. I'm going to Control V, then I'll press Enter. Yeah, so what this does is that you go to see something like this coming up on the screen, the robot spawning to Gazebo. So it will take a lot of time because of the processing unit. Yeah, okay. Yeah, good, yes. So the robot is loading. Let's give it some time. Yeah. So if I zoom in, yeah, okay. So I can see my robot spawning to Gazebo. Has everyone done this? Good. So the next thing right now, for example, now you have a robot now. The first thing I always tell people to do, or myself, the first thing I do when I have a robot, I'm trying to get the topic is to check the topics which are available on my robots. I'm trying to. Okay. All these topics. Sorry. I don't know why I can't type on my terminal. Hello.
Hello?
I'm trying to type on my terminal, but I don't know why it's not working.
Yes. Okay. Try to close this one. The whole window.
Okay.
Yeah. Close it.
Let me open it
Yes,
again.
and now open again. Exactly.
Okay, good.
Yeah.
So we have to launch the robot again from the beginning. Spawn the robot.
Yeah, that's right.
Okay, let's try start again. Okay, fine. Yes, so good. So I said the first thing you need to do is to check on the topics available in robot. So the command is ROS2 topic list. Sorry, topic list. So what this does is that it's trying to tell you the topics that are available on your robot. Now, if you look at this topic right now, we have the CMD World topic. What this means is that it means the robot, you can actually publish to this topic to make the robot move in linear of X and angular of Z itself. So basically now this robot has what is subscribing to what the CMD World topic and is publishing what odometry what data and scan topic. Now, in mapping, we need two things when it comes to mapping. We need what? The scan topic, and we need what? The odometry what topic. And we need CMD val to what? To publish to what the wheel of the robot to go in either what linear of X or what angular of what Z. Now, right now, since now we've spoken about that right now. So now they will not go down right now. I already spoke about what a map is now. So now we're talking about what simultaneous localization and mapping. Now, the word simultaneous localization and mapping already gives you what? An idea of what it is. Do you get? So now what it means is that you create a map and you need to localize yourself, localize the robot in that map. You're going to tell the robot to go for one coordinate to what to another, or one point to another. Now in ROS2, now let me just give you a brief history about the ROS2 and ROS1 packages in mapping. In ROS1, we have two types of packages, which is what the G mapping package and the Hector what package itself. Now, basically, the G mapping package was subscribed to what the odometry data was, and it was scanned what data, which is coming from the LiDAR or from the camera. It can be a stereotype camera or a RGB camera. But in ROS2, we have two main types of what package we really need to use. We use the SLAM2 box, which is created by Steve McKinsey, and was the cartographer node. Now, the SLAM2 box node is a node that people all over the world as roboticists actually use in what? Creating what? A map. Now, in Slam Toolbox node, we have types of Slam Toolbox node. We have the offline, we have the what? Synchronous or asynchronous node. So basically now, the offline node, that's what we'll be talking about right now in this project. Right, the offline node has a lot of favorite and a lot of what features, in the sense that you can need to localize your robot and you to say, okay, localize the robot, and the robot can generate the map as is what localizing and moving what in the environment. So the offline node, you can actually what record a laser scan data using a ROS bag node, a ROS bag. Then when you record the laser scan data using the ROS bag, you can actually replay that laser scan later anytime you want to use your bag data, then to record the map and the rest right now. So now to see our what offline sync node, we will go to the code editor. Is anyone following? Hello.
Yeah. If you want some feedback, Davies, you can.
Okay.
You can also see the stream, the chat. That way you know.
So I want to show the offline node on the IDE, still loading.
It looks like there are some connection issues there.
Yeah, probably.
Okay, this is, can you advance in the meantime something?
Yeah, okay. Yeah, so okay. So the thing is that now the offline mode, now in ROS2, you can actually use a Python script or XML Word file, launch file to what launch what nodes. But in this sense, since I use ROS Foxy to develop my packages and my node and everything. So now I will always explain what this means. So this is our launch file that launches what on an offline what a sync node, which is for the offline node in Slam Toolbox. So basically now it's a Python script, a Python file. So what we did first is that we did from the launch file package, and we imported the launch description. Then the next thing we did, since it's a Python file, we imported launch_ROS.action, which is an action node itself. Then we imported this library itself. Then we created a function that returns backwards this, right? Now, what this means is that, okay, we have get package share directory. What we do is that, okay, this package we call robots is the package we're using in our project. You get? So in the param folder, we have what? A YAML file that contains the offline mode. You get? So now we're using what? The Slam Toolbox word package, which is linked to what? The package name. Now in ROS2, what happened in ROS2 is that you have a variable name that links to what a package is, always like that. So this Slam Toolbox package is linked to what is variable name. The executable is what the Slam Toolbox node. Then the name is the Slam Toolbox node and the screen. Yeah. So I will explain the map params file. But first thing first, let's launch the node, the offline node. We already have our robot here.
Yeah, we can try to open the ID again whenever you want.
Yeah, so launching the node. Good. So now you can say, okay, why is my RVs not working? Why? But why look at that visualize what my map, my robot and everything. But what you've not done is that you've not run what the RVs what node. So the next thing now, you know what RVs is for? It's for visualizing what sensor data and nodes and everything. So now we just copy this command ROS1 RVs2. Then we open the new tab, then we paste it in here. Sorry, I'm launching the first node. Control C, Control V, open. So let's wait for it to get open. So now we're trying to get our map using the offline mode. Now we have what RVs, right? Now, can you see? Okay, let me open. Yeah, so the thing is that first and foremost, it's what they call quality of service in ROS2. Quality of service means it refers to the configurable parameter that define the behavior and reliability of communication between ROS2 nodes. Now, it's just like you communicating between nodes in ROS2. You need the quality of service. And quality of service allows you to control various aspects of message delivery, including reliability, timeless, and what resource usage. Now we already launched the offline node. So what we're going to do is that we're going to add the by topic. We'll add the map topic. Then we'll set this. Now I just spoke about quality of service. Now there's two types of quality of service. We have reliability policy, have durability policy. Right now, good. So now what's the thing? What happened right now is that okay, the map was trying to update to get published to what and visualize what in our base itself. So we add our laser scan topic by topic. Then we come here, down here. Then we set the laser scan from this to system defaults. Then this sets, no, sorry, it's supposed to be variability level. Then we have this as volatile. Then let's try creating. Now you say you can be like, okay, I've not seen the robots now in RVs. So what you need to do now is to add what the robot was description to RVs. Then go down, you come to this tag, then you go by topic, the description of the topic. It's going to be robots. Just go description. Now we cannot see our robots what in ROS, right? So now the next thing now we need to do right now is, okay, how do we get the map of the environment? So how do we get the map of our Gazebo World? How do we get the map of where we are? We use the robot and a LiDAR and its RGB camera and sensors. So the next thing we need to do right now is to launch our Teleop Twist keyboard node. So the command right here is here. So to move the robot around to generate a map. So we can just leave this and we can paste this. Now, good, fine. Now, the thing is that, okay, we have what? Two things being launched. We have what? The Gazebo World, which is our world which the robot is being spawned in. And we have what? ROS. So now we want to create a map of the environment. So what we need to do is that, okay, now what is happening right now is that the CMDVL node, the Teleop Twist keyboard node, is publishing to what the command velocity topic to make the robot move what's in the environment. So now we just press I. Sorry, a little bit. Let's decrease the speed so we don't go too fast. We press I. Yes, we go press I. The robot goes forward to get the map. Press the J, the turns angular velocity of -z. Then press I again to move forward to get the map. Now that's okay for now. Just explain this. So now we can see now in our ROS, we've generated a map of the environment using what? The SLAM toolbox, using the offline sync node. Now the next thing is that, okay, I have a map. What should I do next with it? How do I save this map? How do I use this map in localizing my robots? How do I use this map to send points, robots from point A to point B? So that's when the map server node come in place. So basically, what the map server node does, just like ROS1, when we have a map server node that saves the map in which you can replay later to the robot to localize the robot, to be able to send points or another, to be able to use A-star algorithm, to like D-star algorithm and the rest. So basically now we now say, okay, we now have the nav2 map server node. So basically what this offers is a service for loading a static map. It is frequently used in robotic application to give other nodes in the system of a map representation of the surrounding. So now what we'll do is that, okay, right now, we need to create a directory called maps, which I've already done already, so you don't need to do that. We'll just copy this line to save the map. Then we will go back to web shell or bash. First thing, close this. Note, do not close the SLAM toolbox node, which is running, because you've not saved the map yet. So until you save the map, you cannot close it. So then I open a new shell. Then I just paste this in here. Now I'm not in the maps directory of my folder, which is located in my package. Do you get? So now the next thing now is what is the command to save the map? I don't know the command. How do I save this map to use it for localization and path planning? So basically, the command to use to save the map was ROS2 run. That means you're running a single node, right? nav2 underscore master, which is the package name. Then this, just copy this. Then we'll save the map. Control V, then we'll press enter. So now we cannot say that, okay, our map is saved. Then if we ls, we cannot say we have, since we made the map mapped, right? Then we have two files, the .yaml file and the .pgn file. So now let me explain what these two files means. Now, what the two files means is that, let me open it on the shell. Let me cut it on the shell, then cut YAML. Good. So basically, what this is saying is that, okay, I set my map and it generated two files, which is the PGN file. The PGN file means is like description of the map. It can be how the map is being structured, like the picture of the map. And the YAML file is like, okay, the origin, it shows the origin, the orientation of the map, the details of what the map entails. Now, when we're talking about loading this map and using it for localization, we won't use the PGN file because what is the picture of the map. We're going to use the YAML file because the YAML file contains like the XYZ and the coordinate of the map, which is the origin of the map and the resolution of the map itself. Now, good. Now we're talking about that. Let's not talk about the parameters that are very, very, very important, which are used in what? In mapping. Now, important parameter used in map are the Odom frame. If we take a look back here, we go back to our what? Terminal, right? Then we open the terminal, we open a new. Good. So now, in ROS and in robotics, in ROS in general, there are some frames we need to keep in consider. We keep very, very important and we need to notice this frame. Now, for example, now we need the Odom frame. Now, if you're talking about dealing with real hardware, like trying to like program a robot using ROS2 control, you can actually program the robots. You can actually publish this Odom topic over to ROS. Then you subscribe to the SLAM toolbox. Now, the other topics is like you tracking how far the robot has moved in the map or in environment. Now, so basically it has to do, using a Google folder, it has to do the number of ticks the robot has counted in one revolution. Like a one revolution, you say, okay, how far this robot, what's the number of ticks the robot has counted? Now, if we write ROS2 topic lists. Now, good. So now we have some topics being here on here. We have the CMD and the rest. We have the odometry topic. So now the odometry topic is what has to be the topic you pass towards the Odom frame, which is located, the parameter is located in the YAML file on the launch file of the SLAM toolbox node, which is the offline node. So what it does is that this specifies the name of the odometry frame of your robots. So now, if you have a robot, and you have a odometry topic which is published over to ROS, what you need to do is that you have to put the same name of topic on this passing to this parameter. If you put Odom, if you put this Odom, there will be a problem. The reason why is because we're not passing the same name over to this Odom frame. Do you get me? Now, we're talking about right now. So now we're talking about the map frame. Basically, the map frame has to be the fixed frame of your world. We are trying to generate a map, a SLAM toolbox, Gmapping, and the rest. Good. So now this specifies the name of the map frame of your robot, which means the topic, which is the map frame, which is published to, which is the fixed frame. Now, the base frame, what the base frame means is that the center of your robot. Now, if you're talking about the base frame, now the center of the robot is like a fixed frame. It's not like a fixed frame, but like a frame in which we have all child being connected to. Now, for example, now, if I go up here now to my robot right here, and I explain something, I'm trying to explain something now. For example, now you're trying to attach in real hardware, you're trying to attach this sensor to this robot. This robot has to have a base frame, which is the center of the robot. So basically now you have a LiDAR sensor that is published, that has a driver that is publishing the SCAM topic. Now, this won't work and be displaying always unless you connect this child frame to this base frame. So that's why we're talking about static transform and TFs and the rest. So right now, that's what we just spoke about. Now, the scan topic, we just spoke about the base frame. Now, talking about the scan topic has to do with the topic in which the LiDAR sensor, it can be the LiDAR sensor, it can be the kinase sensor, it can be the RGB camera, it can be the real sense sensor is publishing itself. Now, that topic in which that LiDAR sensor is being published, is publishing on, that is the topic you pass in here to the scan topic to get the scan of the environment. Now, the mode, talking about the mode. Now, I spoke about the offline mode. Since we are going to be using the AMCA node, we will be localizing the robot using the SLAM toolbox node to the offline node. So, and the SLAM toolbox node, let me open this code, whether to work now. Let's work. Still loading.
Let's hope that now it loads.
Yes, sir. Okay, yes. I put it loads now. network.
I don't know why. I cannot
Okay.
know why.
Okay. Let's continue. Sorry. So okay, the thing is that we now spoke about the scan topic. So basically, the topic in which your LiDAR sensor, your camera sensor, your stereotype sensor, your RGB camera sensor is publishing. That's the topic that you pass in what? That's the topic that you pass in to this frame itself. Now, talking about the resolution of the map, the resolution of the map specifies the resolution. You can reduce the resolution for like minimum range, or you can increase the resolution for maximum range in the sense of the LiDAR. It depends on how the range of this LiDAR is. Now, that's all right now. So now I'm talking about the TF frame. Now, in robotics, we have frames, what they call transform. So basically now in SLAM, there has to be a complete frame, which is the map to the odom, to the base link, and to the other sensors. Now I already spoke about, okay, fine, we have to have sensor connected to the base link. For example, now we have a camera link connected to the base link. There has to be a TF, that a static TF2 static transform that connects what this camera was frame to what this base was link. Then the odometry frame is the frame we passed in here, right? We passed in here. This is the frame, like talking about you're using the wheel encoders. We know that, okay, how far the robot is being traveled. So we use this to track how far the robot is in the map, or to know, okay, this is where the robot is in the map and everything. Then the map frame is the map node that we launch. So if we launch this topic, this should be displayed in the IDE, but I don't know why the IDE is not playing right now.
Are you running on incognito mode?
So?
Are you running the browser in incognito mode?
No, just normal browser.
And the browser?
Yeah, like normal browser. Yeah.
It's incognito mode?
No, it's not.
Okay, then I don't know. It should open, unless it is in incognito mode, you know? Which browser are you using? Firefox.
Pardon? Firefox.
Okay.
Yeah, so I'll just explain it right here. So we're really not robots. So the map topic, the odom topic, the base link, and the camera link and everything. So now we spoke about how to map. Let me just give a brief review before I go to localization. So now we spoke about how to map our robots, able to calibrate the robots, what's in the environment is the Gazebo World, and also we spoke about how to save the map using the nav2 the nav2 map server node. So now talking about localization, now let's go to localization. So now localization, the word localization, if you say localization, what comes to your mind? Now localization is the ability for the robot to go to localize itself in a specific map or a static map itself. And this localization algorithm can only work when we have like encoder data and we have IMU or GPS. Now, for example, now GPS, now you're trying to track how far the robot is, and you know GPS is not actually very accurate unless you like fuse the IMU and some other orientation sensors together. Yeah. So and it also happens in localization mode. You can't depend on only odometry. You know why? Because they can be wheel slip. For example, now you tell the robot to go from point A to point B. They can be wheel slip, and the robot can track how far it has moved in the map itself, unless you like fuse it with an IMU using the EKF package, which is the common features package and the rest. So now this question still goes to the where am I? Where am I? Where am I? I am on the map. So how do I localize myself in the map? This one can be said to be the estimation of robot poles, position and orientation in the environment. Estimation means like, okay, where am I in the environment? Due to the position, it can be X, Y coordinates, right, in the environment. This involves utilizing the sensor data in which is retrieving from the encoder, the IU, GPS to get the state of the robot in the map. Good. Now, let's talk about AMCL. AMCL is like a very popular algorithm which is used in localization in the sense that, okay, we use particle filters to provide guess to where the robot is in the map. So basically, the lesser the dispatch of the particle filters, the accurate robots, the higher the dispatch the robot is still trying to like get itself in the map and itself. So this is like the particle filters to represent the robot's possible pulls and updates. Update them based on the sensor measurement, which can be coming from what? Can be laser scan. You can use a laser scan match and the rest, odometry, what big and the rest. So you localize what in the AM system is widely used in robotic field. It's actually used in industries, used for hobbies, used for projects, used by master students, used by PhD students for research and purposes in localization. Good. So now we're trying to now talk about AMCF. So let's try and localize our robot with AMCF. So first thing first, we have to close our first node because we're trying to localize our robots. So we'll close the first. Everybody, are you still here?
Yes.
Good. Is the audience following?
Yes, yes, they are. So don't worry. You don't worry.
It's good.
You keep on doing.
Okay.
We have done some tests in the background and see it should appear your post.
Yeah, I just want them to follow up. Yeah, that's the main issue. That's the main thing. Yeah. So okay. Now talking about AMC, remember we already saved our map, which we're going to use what for what? Localizing what? Our robots. So now the thing we need to do now, I close all the time now so I can start from beginning explaining the AMCN node. So everyone can get. So I will go back to the top most, then spawn my robot again in Gazebo. So let's copy this. Okay, copy, Control V, good. So wait for the robot to be installed. Now, yes, we're good to go. Good. So this robot spawned to Gazebo. So we want to localize the robot to where it is in the map. So the robot is right here. So now, talking about AMCA node, I already spoke about AMCA node. I'm trying to use particle filters to guess, like, where the robot is in the map. So basically, the lesser what the dispatch, the lesser the particle filters are, the more accurate it is. So the higher it is, it's still trying to localize itself very well. So right now, I copy this. Let's copy. I will come back to explain all this, but let me just go into the main details.
Yeah, we are 5 minutes to go.
Oh, sorry, I need to be fast.
Okay. And my colleague told me that maybe by doing a complete reload of the whole page, maybe we'll solve the problem of the IDE.
Okay.
If you need it.
Okay. Once I do this. So now, if we launched what's the first thing we did is that we spawned with our robot into a Gazebo. Then the next thing is for you to copy this command line here, this command line, then paste it into Gazebo. What it does is that it's what publishes what to AMCL for Alvis to subscribe to it. So that we open Alvis for us to visualize. Control C. I need to be fast. No, Control X. Sorry. Control V. Now, good. So now we're waiting for what? Now we want to localize our robot. Now the thing is that, okay, you'll be like, oh, I can't see my robot. Why is my robot not localizing itself in the what map? So now in ROS2, we need to set a 2D post estimate first, because if you can see right here, it's trying to say AMCA cannot publish a post or update the transform. When it's trying to say, you have to give it what initial position. So let's give it an initial position first. Good. So now I already spoke about what quality of services are. So we need to go back to what quality of a service to now to like put our services and the rest. So now we go to add topic, then we go to map. Now we can't see the map yet because of the quality of service. Then we put this map service to reliable, and we put this to transcode local. Good, very good, nice, good. So we can put here, we can do this here. Set it to 3 view. Good. So now you can see, okay, I've not seen my robot. Why? Now, our robot is supposed to be here in the world. If we check right here. Good. So the next thing we need to do is what? To set the post array, which subscribe to what? The particle filters. Sorry, I need to be. We set our quality of service to. We set this towards system default. We set this to let's say. Okay, robot pose, robots. Sorry, time.
Okay, go ahead. Don't worry. You're doing great.
Yeah, okay, yeah. So we put our robots right. Now we need to know, okay, where's our robot what in the environment? Good, right? So let's give it a 2D pose estimate of here. I don't know why this is not subscribing to that. Okay, let me put my laser scan topic. Added by topic. These two, let's increase this. I need to check this well.
Have you selected the proper topic in the pose array?
Okay, let me check that.
Topic, you don't have the topic in the pose array.
Okay, yes. Sorry, I skipped that. Sorry, that was a mistake.
On the side of topic, beneath that.
I don't know why it's not up.
Oh, yeah, on the right hand side, you can type there, right? Where it says topic, then on the side, underneath error. Can't you type underneath error? No, underneath that one.
It's not showing. I don't know why.
Okay, then go to the. Let me help you on this. Let's go to add. Go to add again. Display. Add display. Add a new display. Yeah, and then wait. Particle cloud. No, by display type. Particle cloud. No. Up. At the top. Up. No. At the top.
Okay.
At the top. Top. Particle cloud.
Yeah.
That one. You want to display the particles, right?
Yeah,
now
sure.
go down and configure that one for the proper topic, where it says topic. You need to type on the topic right side.
Yeah.
So besides topic. No, but you are not specifying the topic there. Exactly. There, exactly. You have it there down. Yeah, there, that's it. Correct.
So now what I was using ROS1 terminology. Sorry.
Yeah. Okay, no problem.
This particle cloud. Sorry. So what we need to do now? Okay, let's localize our robots well in the wall in the ROS. So what we need to do? We need to spin our robots. The reason why we need to spin our robot, we need the laser scan data to get information of our environment and the rest. This is not okay no more. Okay, so now we do this. ROS2 run. Let's type this command. ROS2 run. So we already have a robot being published to our page already. Then if we move on robot 360, let's see. I can't see the particles. I don't know why. Oh, this is correct. I don't know why this is not. Okay. So the thing is that, okay, you remove your robot 360, you're meant to generate a particle filter. Let me go back to the slides. So this is what's meant to happen is this. So what is going to happen is that if we move, so if we move our robot 360 using dot, we configure our quality of service. We're going to have like a dispatch. You can see right now in this picture, we have, okay, so the lesser the dispatch of the particle filters, the more accurate the robot is. So the higher it is, the more you need to make the robot being accurate than the rest. So that the ways we can use to localize your robots for what proper words localization. Now, the best way to do it is that you have an IMU and you have like an odom, like you have an encoder that's publishing odometry topic itself. You can't just rely on what odom topic because you can have like a slippage and you can have a lot of errors and the rest because of the noise and everything. So now, so for you to have a very, very precise word localization, you can fuse that IMU with what the word data, odom data, then use the EKF package to make everything polite and everything works fine. Good. So there's also another command that we can put in here. So I think I'm done. Yeah.
Okay, perfect. Then thank you very much, Davies, for your presentation. Thanks a lot.
Thank you. Thank you, Ricardo.
Okay.
Thank you, Davies.
Yes, excellent. And it was a little bit troublesome, but you finally achieved it to reach to the end.
Sure. Was my ID wasn't working. I don't know why.
Yeah, that's I understand. That's a lot more stressful. Yes.
Yeah. Thank you.
Great.
Okay, great. Excellent.
Thank you, Ricardo.
Davies.
Thank you, sir.
Okay, so now let's start the Q&A section. So dear attendees, please put your question in the question tab, the Q&A tab. So we're going to pick the most voted question to ask the speaker. Okay.
Exactly. Let me check on my tab here already. So in the meantime that the people, they are posting the questions there, then let me start with one of my own. So Davies, you have shown how to make a map and then how to use this map to localize the robot in the environment, right?
I said it earlier because of the time. I said that it's possible for you to localize the robot using the map. Yeah, because of the time I couldn't do that. So I need to just use AMTL file to like describe. Yeah, and I was trying to open my IDE to display that wasn't working, to change the parameters to localization parameter to make everything work. But it wasn't
So and we know that this software there work step by step if you go, because we have checked together also prior to the conference and we took those images also from there. So we know it works. But then my question is, what would be the next step? So in order to have a navigation system in a robot, what will be? So we have seen mapping and then localization. What will be next?
Yes, thank you very much for that question, sir. So basically now we know in ROS1 we have what they call move base. So basically ROS1, what it does that what ROS2 does is that, okay, you save a map, right? You have a map, then you save with the nav2 map server. So we have what they call DWB planner, which is for nav2 stack, which is created by Steve McGinsky. So what you need to do is just to load that. You can actually have a launch file that has all the localization node, like you spawning the URL and the map into what RVs and visualizing the map itself. Then you need to have some parameters, which is located to what the DWB local planner. Then these parameters can be tweaked according to how you want your robot to be to move in the environment. Now, for example, talking about the parameters now, You can say, okay, you want a robot to be able to pass through a very narrow corridor, or you want a robot to be able to like have an in-place rotation. That parameters you have in that DW, the local planner, that you can change and tweak, that you can make your configuration very accurate and your robot very, very smart. Yeah, and it's also possible for you to write your own planner. I was about to write my own planner. When I say rules, yeah. So okay, write your own planner to make your robot to be able to navigate from point A to point B using like the A-stars and all the rest algorithms. Yeah.
Maybe this your own planner can be a next talk for the next year of the ROS.
Yeah, that's pretty hard work.
Yeah. Okay, let me ask you another question from the audience. So Roberto Siker says, in ROS2, would you prefer cartographer or SLAM toolbox for mapping, and why?
Very good question. I love that question. Very good. Now, the thing is that SLAM toolbox has been taken around, has been explored in different areas. Now I read a paper by Steve McGinsky about SLAM toolbox. He explored the creator of SLAM toolbox, Steve McGinsky. So he explored this SLAM toolbox in different area of different region, and so to show how accurate the robot can be able to map using this package. So now, if you have a very large, let's say a very large environment, the SLAM toolbox is very, very smart to like map that environment. Now, talking about cartographer, I won't tell you to use cartographer. The reason why, because it's invented by Google. Google did not maintain this package for a very long time. So I will tell people which are getting into ROS2 to use the SLAM toolbox, because it has a lot of features. It has the localization mode. It has a lot of that's the offline, which you can use the ROS bag to map. You record a laser scan, then you can play it to the ROS bag to map the environment and the rest. You can actually check. Can you see my screen? You can actually check.
No, now, but we can. If you want to share something, we can switch.
I would like to share.
Now we can see it.
Yeah, I would like to share the GitHub repo of SLAM toolbox. So if you can just go down and explore it. Yeah, loading network pad. The network. Let me try again. Okay, so it's loading right now.
What are you looking for?
Yeah, I'm trying to get the SLAM toolbox GitHub repo so I can.
Okay. Okay. Then so let's move in the meantime to another question here.
Okay.
And from Klaus Lex that says, do you have any recommendation for 3D SLAM instead of?
Pardon?
If you have any recommendation package software to use in order to do 3D SLAM, because you have been showing
3D SLAM now, that's OutTab SLAM, right?
Yeah.
Yeah, so OutTab has an official package you can use. You can check online for the OutTab map and SLAM. I had a project working on that, so you can check OutTab.
Yes, but I'm not sure if it's done in ROS2. If it is
it's not that's the only thing now. So we're trying to you create something. So basically in ROS1, but in ROS2, we're still working with 2D for the meantime. And yeah, so if you're trying to get like using a visual odometry, that you have a real sense camera, that you want to do like 3D SLAM and everything, you can look at OutTab, yeah, or OB SLAM and the rest, yeah.
Okay. Then
yes,
one final question for you. So the answer is RTAB map. Okay, try that one, Klaus. Then David White says that, do you have any recommendation for tuning SLAM?
Yes, I do. I would like to talk about that right now, but my time is really small, so I just have to make everything. Yeah. I have a little thing to explore. So if you're trying to tune SLAM, there are parameters that are located in the offline mode, or you can check online and everything, offline, online, and everything. So you can tweak those parameters for accurate what map you get. So basically, you don't just go into like the parameters and you just start tweaking. You have to know what each parameter means.
Yeah.
You can, because if you go on the parameter and you just start tweaking, they can just have a lot of problem, with your package, and you can just dismantle everything. But if you know what each parameter means. You can know, okay, if my robot doesn't have a high resolution, I can be able to tweak this parameter to be able to suit my robots in the world and the rest. Yeah. So you have to know, to answer that question, you have to know what each parameter is. Then not tweak it.
Yeah, go to the documentation, understand the parameter, and then you can start tuning and modifying a little bit. Yes. Okay, then Davies, so we don't have more time. Thank you very much for your presentation again.
Yeah, I wish I could do more, but
yeah, you did your best.
Thank you.
It's very good, very good. Thank you.
Thank
See you around the world.
Yeah.
Bye-bye.
Thank you. Bye.
Great. So, dear attendees, now you should see a small box just appear on the chat zone. So, it's where you can rate for this speech. Please take a moment and rate for this excellent speech brought by Davies, because at the end of the conference, we are going to announce the best speaker of this ROS Developers Day. So, let's continue for the next section.
What do we have next? Is another speech, right?
Yeah.
But this is a little bit more special.
Yeah, the open class.
It's because it's not a, exactly. It's not just a speaker. It's an open class. The open classes are the events that we do every Tuesday in the afternoons. They are open, and then we teach about ROS to the public. So it's in the same page, and you can come. It's for free for everyone. But today we have another one, right?
Yes, but before that, it's very important that we need to remind the attendee to get the ROS chat open.
Yes, that's right. And then, in order to get ready for this open class, remember that there is a button here underneath, and then it's to open the ROS, or it's in the Docs tab if you are inside another ROS already. So go click on it and open it. Get ready. So.
Okay, so while we are waiting the next speaker, getting ready, let's have some fun challenge right now. So we are going to do a prize quiz right now, and the winner is going to get an I Am ROS Developer t-shirt and a coffee mug, just like those one here showing. Yeah.
And a t-shirt like this.
Yeah, this is sponsored by Starbucks Coffee, which is an online remote cafeteria built by the Construct using ROS2 and OpenRMF.
Yes, and then, so how this challenge works, let me explain you. So how can you win the t-shirt and the mug is by watching a video. We are going to project a video right now, which talks about the Starbucks coffee. And then at the end of the video, you are going to see a question that you can answer by watching the video. So the first person that correctly answers the question on the chat will win the t-shirt and the mug.
Yeah. So go ahead and see ya.
See you in 5 minutes.